Alright, I had these two cheap little wireless infrared cameras, and I hacked them apart because they're basically useless the way they were. And I found out I had two little board cameras, and I already fixed one up, which is pretty cool. And I even made it into a little night vision pan and tilt with my Arduino. There's one servo. This servo right here, it runs the tilt, and the one it's sitting on in this project box is the pan. That's it. I'm running the camera off of this through a 5-volt regulator that I bought at Fry's Electronics. Ran it. 5 volts is exactly what the camera needs, so that's pretty cool. And running it, the pan and tilt, is of course my Arduino Uno. It's a clone Arduino Uno with a sensor shield up on top and parallax joystick. This little joystick controls up, down, and from side to side. It's pretty cool. I just had to figure out the wiring because the documentation really sucked. But pull up, side to side. I'll try to fit everything inside this project box. I think it'd be worth having. Pretty cool. But the camera works like this. You can see my finger back there moving around. Side to side. And I built the project box for that camera as well. It was actually a double A battery holder, whatever you call them. And it'd be nice and easy to move for the servo, because this servo is a little 3-volt servo. The other one's a big 5-volt. As you can tell from its real punchy attitude. But pretty cool. What I like is this joystick though. It's a lot of wiring to get it to go, and a lot of figuring out too. I'm glad it just didn't blow it. But it does work. Everything's fully adjustable, even the way it sits. It's adjustable by, and here's the picture it's putting out. There's my TV. This is my computer room. Actually, my project room. And you can see it goes pretty wild, pretty quick. But the program is pretty easy. It's actually made for just one servo, but I went and modified it and added the second servo. Changed the wording as well. But I didn't think it was going to work this easy, but it actually does. You have to, make sure you put everything accordingly. But this delay, I really don't know what the function of that delay would be. I'm trying to figure that out. But this is how these numbers are what you set its stance as is. That's why this number is different from this set of numbers. Because this stance right here, the 65, actually tells it to sit level and look almost straight across. If you change it, make it 100, it'll look down when it starts out. I wanted to make it 65. It looks pretty level. And then the 170 and the 179, I didn't want it to tilt too far back, because that's when you start running into issues of the holder hitting the servo. Now I'm going to remount the servo to the middle, because I found out, of course, on this unit it's hooked up to the side of the camera, and it pulls it to the side first, and so it gives away. If it's in the middle, it's going to be even, more even grasp, more even movement when you're pulling it down. But it's pretty cool. The smaller servo came off of a small chopper an RC chopper. I gave up chopper flight because I just don't have the reflexes for it. And the bottom one came off of another helicopter, which was a size 30 Nexus. It's an ancient helicopter, but I don't fly them anymore. I'm more into airplanes. They're easier to fly, and you could glide down to a crash instead of crash and burn, and you just went up $700 or $800, not more. The joystick was about 14, 15 bucks. And the camera's also focusable, so it's cool. You can focus it out or focus it in. But it's a pretty cool little item. I tried to house this 5-volt regulator inside the box. I might even be able to get the battery pack in there. That would actually be cool to make a plug-in, so you just plug them in. I'd have a little bit more wire play as well, which